Alright, so we're going to look at special patterns first. And this takes off the notion of what we had when we did the activity in class, where we looked at what happens if I take a plus b, I square it, get a squared plus 2ab plus b squared. And if I have a minus b squared, I get a similar pattern, but the sign of the middle term changes. In fact, a lot of our focus is on what's happening with the middle terms here. Because of the way FOIL works, the outer terms are fairly consistent with these special patterns, and even with what we do further. The firsts combine to make the first term, and the last combine to make last terms. But it's the outer and inner, those two things that combine, that define what's happening with the middle term. And so we have what we call these special factorizations, or these special products that we can use. And remember, our game is to go backwards and forwards. So if we have a polynomial, we want to find out what pieces were multiplied together to make it. And so if we're finding out what pieces were multiplied together to make it, we're going to start with our right-hand side and go to our left-hand side. And let me get the other two here. We want a plus b times a squared minus ab plus b squared. And that's my addition of cubes. And a minus b a squared plus ab plus b squared. And that's my difference of cubes. Alright. And these are in the front of the book, in the blue pages. I think the book calls them special factorizations. But our game here is we're going from the right-hand side to the left-hand side. And so we need to see these patterns coming up. So we're going to start by looking at this thing here. It's called the difference of squares, because I have a square and I subtract them, which is a difference. So we'll start by looking at the difference of squares. And we'll come up to that again. So difference of squares examples. Difference of squares. And so we're looking for a pattern. And so let's look at 14 in the book. X squared minus 25. So if I come up here, that's my left-hand side. And I'm wanting it to be a squared minus b squared. That's what I'm hoping this pattern is. So I'm saying if this is a difference of squares, a squared equals x squared. And that means a is the square root of this, or x, and b squared equals 25, which means that b equals 5. Now let's go back up here. We're going to keep back and forth, jump up. So the pattern is I have a squared minus b squared. It means that it came from a plus b times a minus b. I can do that. I can come back down here. I can finish the pattern. I can say a plus b, so a is x plus 5, and a minus b. Okay, that works. Let's FOIL this, make sure it does work. So my firsts, x times x equals x squared. My outers, minus 5x, and my inners plus 5x. And then in my lasts, a negative times a positive is negative, and 5 times 5 is 25. Now notice, again, most of the work here is with the middle terms. I have a negative and a positive of the same thing. They'll cancel, or they add to 0. That leaves me with x squared minus 25. which is what I started with. And so when we have what we call conjugates, because it's the same two things with just the sign in the middle difference, we call them conjugate pairs. They'll become important when we look at fractions and imaginary numbers, where we need to work with getting rid of middle terms. And it does. It gets rid of all middle terms. All you have are these squares on the end. And that is the difference of squares. And we can go backwards and forwards with it. And here, we start with the difference, and we break it into these components. So let's look at another difference of squares that might be a little more complex. So we'll look at number 20. So I have 121 y squared minus 49x squared. Well, I want to make sure that it's a difference of squares. It looks like the pattern. I have a squared variable and a squared variable. I'm not 100% sure of the numbers, but we'll say, okay, well, if I want this to be a difference of squares, a squared has to be 121y squared. So what would be a? So I run to my calculator and I take the square root of 121, and it's 11, and the square root of y squared is y. So, well, that term's going to be nice. That's going to work for us. And then I'm going to look at b squared as being 49x squared. Now, 49, that's one I happen to remember, is 7 times 7. X. And so we have an A and a B that comes out of this nicely. And so again, completing the pattern, 11y plus 7x, 11y minus 7x. And we've used our difference of squares. And so that works nicely. Okay, in the next video, we're going to look at the perfect squares. Both positive and negative, and how they look and how we can reverse them.